0 here. I feel short. Getting taller, getting taller. That should be good right there. Okay, hi. Been playing on Minecraft again a little bit. Okay, so last video I showed you this cool stuff here. So I'm actually not going to go with this design here. After thinking about it for a little bit and kind of running through the design in my head, I realized that this actually isn't the best way to do it. So the best way to do it is ironically the same way that we did the addressing for the memory. And as you can see, I've done a lot of work here. This addressing here for the memory used to be 16 blocks wide. Now it's only 8. So that's good. Save some space. Unfortunately, because I changed that, I have to change all of these address locations. So that's, 64 different things that I'm going to have to change and clone and add and stuff. And yeah, it's going to take a while. But another interesting thing that I did is I found a way to make this look seamless. Like, as you can see, there is no command blocks that you can see. And then you can just kind of see how it goes all through here. And the way I did that, which as you can most likely guess, is I put the command blocks actually underneath all the blocks there. So I've got some under this corner, that corner, that corner, all those corners. And then over here, I did the same thing, only it's this one will drop down and put some redstone onto there, which will then invert it, basically the same thing as I did for the X, Y, and Z over there. Now when you see it work, it will look seamless, which is, kind of nice. So if we just turn this on, and we're just going to go every other one. And that way you can see how all this works. So when you go up and you look above, it looks like an actual, kind of like a wire. Like this wire goes through over here, it goes up onto here, goes this way, goes over here, goes this way. And it works, right? So that's kind of what I'm going with. And then, you can kind of see the old way that I had it over here. Yeah, this is going to get made better. And it'll look seamless. So I think it'll look all around better for the processor itself. And then because I shortened these up, I'm actually saving space as well. I put 3 blocks of space in between these two. I think that's enough. There's 8, 9, 10, 11, 12, 13 blocks in between the addressing here and the memory here. And that's just filled up with the actual addressing stuff. These are a lot smaller now, more compact. And then I managed to get all of this to work one by one, because what I'm doing is I'm just replacing actually the quartz with redstone so it doesn't touch the command blocks at all. So that's just a really simple command. This one is change it to quartz. So fill from here to here with quartz, and then all we're doing is we're just replacing the redstone blocks. So really, really simple. And then I also decided to go and change the registers here. The other way it was nice, but it's adding a delay into this that, once I get down to the timing, and I'm going to try to get it like as fast as possible, any delay is going to be a no-no, something that we do not want to do. So just to show you how this works now, so this is going to be the gold lines that come off of each of these registers. All this block is doing is cloning this last block here to this last block here. I got that off of my binary counter type thing. So then we do this, and then it just saves it into here. And then it immediately reads off onto the address bus, which is kind of what we wanted to do. And then I can do the same thing over here with the instructions. This here and this in here is identical. There is no difference. Even the bus here, they're identical, no difference. So that was really, really easy, because once I got this one built, it's like, oh, hey, I can put that over here, and I just had to clone it. So that's real easy. And then because those are registers and they work like registers are supposed to work, when I turn off the data here, and I just put these switches here so I don't have to keep flying up there because that was getting kind of annoying. So yeah. Now you can see all the data on the data bus is off, but the registers are still holding their data. And then if I want to overwrite, then you just clone. There you go. Yep, pretty easy. And then let's say that I have, hold on, let's put a pattern back in there. And that piston you heard was that. As far as I know, there aren't any pistons in any of this so far, which is a good thing. So we're going to put this here, we're going to put this here. So those addresses are saved. Now we're going to change the pattern to this one. Turn off this one, turn off this one. So it was every other one, now it's the first 4. As you can see, the data line shows that it still goes through all the way, even over there. It's the first 4. But then if I want to overwrite this, I don't have to like flush this out or anything. I can just go and do it immediately. And it just reads it. So that's kind of cool too. I'm just trying to make this as efficient as possible. So yeah, so far seems to be going pretty well. I've got a lot of busy work to do with redoing all those addresses over there. Yeah. But hey, let me show you how the addressing works. The addressing for the instructions. Okay, so I've got the first one set up. It runs off of this last one here, because remember, that one has to be saved. It's the same as over there. That last bit is always going to be high, and that's how I know that it's an instruction. So once we put this over here, it's not going to do anything with this yet. And that's because with the purple here, you note that this is for the timer. When this ticks, then it will do something. So you can see that lit up right there. And only if the correct one is addressed. So that way it'll only do one instruction instead of like multiple instructions. And then it will still do it on a clock pulse, which is kind of what we need for this processor to work the way it's supposed to work. So yeah, really quick video. Hope you enjoyed it. I don't know, I think this looks a lot better. It's a lot smaller, it's a lot neater. It doesn't look so, I don't know, busy, I guess. So, and I was thinking about the memory over here again. I was wondering if there might be a way to make it even smaller, but I think it's small enough, so I'm not even going to worry about it. I think this is good. And then plus I kind of need it to be 3 wide for this stuff here. Well, 4 wide technically, because it's got that middle block there. But yeah. So I need it to be 3 wide just for the addressing to work, so I think this here is just going to have to stay the way it is. Yeah, so a little quick update there. I just moved this out of the way. I'm not sure where I'm going to put it now. I'm going to have to put like an instruction bus, I guess. And then that'll just run to each of the different, I don't know, gold blocks. These 2 over here, the read-write for the memory, those will have gold blocks as well. Those are all gold blocks. These are gold blocks. That's gold block. Those 3 are gold blocks. And then we're going to have a gold block for each math function that we do in the ALU, which I haven't even gotten to yet. But I think it's more important to get the basic stuff. Like if I can take and put data into memory and then move it into one of the registers over here, and then, I don't know, move it to a different register and then write it to different memory or something like that. But do it all like with instructions, like it'll pull off of this first one, run that instruction, pull off this one, run that instruction. Then I think I'll be in a good place to start working on the ALU. So once I can get that working, then yeah, should be good to go for the ALU. So that's the video real quick. Hope you enjoyed it. I don't know. I really like the way that this looks. It's basically seamless. So I'm really happy about that. And then making these registers smaller like that, I think that looks neater too. So I'm probably going to keep those. Like if I need any more registers, I'll probably make them in this same way. Now remember, these are write only, and they automatically read. So these are not the same registers as those ones, because those ones you need to read and write, and it has to be like by instruction, whereas this one is just you write and it automatically shows up. So, I mean, this size here is good for that type of register, but for these ones over here, I might be able to make that smaller. I don't know yet. I'll have to play around with it. And yeah, so I think we'll call this video here, just a little quick update. And yeah, hopefully when all this is done, I'll be able to finish off a bunch of this stuff too. Just like the memory, I could put 16 instructions per level, so I'll be able to put 64 instructions in here. Yeah, so that's pretty much it. Yeah, if you like the video, hit the thumbs up. If you want to see more stuff like this, subscribe. You know the whole deal. And I will see you next video. Bye.